This morning I wanted to look at some of the aspects how the development of Agile is now affecting embedded software development. So traditionally, I think most people are probably familiar with the Manifesto and the principles. If not, you can look these up quite happily online. So I don't want to spend time on those, but I want to really get into some aspects. So first is sitting behind the principles are a number of practices. And for most people, the leading areas associated with these are affecting, from a process perspective, very much Scrum, and from a techniques perspective, those influenced very much by extreme programming or XP. So first, if we briefly look at those before looking at some of the further aspects and the tools that are changing the way we're developing software. So first off, Scrum, many people I imagine are familiar with this basic idea, is that it's built around this idea of a sprint that is a 2 to 4 week period with these idea of daily stand-up meetings, these daily scrums. And the aim is we have this workflow that is time-boxed and aiming to develop an increment of a product over a period. Sitting alongside that, we then have a number of aspects that go along with that in terms of the planning, the review, the retrospective. So these are key aspects, and this is very formulaic within the Scrum process. And it's led by a particular team, and the idea is a self-organizing team with a product owner, the Scrum Master and the team have a cross-functional skills. Now that's again been fairly established and fairly well understood. And there are a number of teams, many teams applying this directly today, and it fits very well as a time-boxed environment. But one of the first things that's come into that is the development of some new tools, and probably the biggest one out there, I'm sure many people are familiar with it, is Atlassian's Jira. So Jira is one of these tools that has a number of features to it, but one of the things being built in now is this ability to help manage the Scrum process. So these tools are very good at collaborative working, and they give us this ability to track and manage work and generate reports for us. So this is the first set of a number of tools that are there to facilitate these principles around the Agile process. If we then look at some of the practices that exist, and I say the extreme program, the XP practices have been the main ones that have driven this. And probably the leading one there, which again has had the biggest influence, is something called test-driven development, or TDD. Sitting around those core practices are a number of other ideas. And underlying the idea of Agile is the main one on the bottom left called continuous integration. Now this is the ultimate aim, and I'll get into this in more detail later and look at the practicalities of this from an embed perspective. But the purpose of continuous integration is that whenever we make a change, then that is pushed through a integration process so that we're consistently validating the design and validating the implementation of the system. And then finally, there's a number of broader ideas around whole team ownership, customer testing, etc. So these two things put together, a very good book actually called Lean from the Trenches, sort of shows that Scrum and XP, that Scrum can act as a wrapper around XP. So we have the Scrum ideas around the outside, and you can see where there's a direct overlap between XP ideas and Scrum ideas. So these two things work very, very well together. Scrum very much to manage the daily activities and the process around it, and XP are the supporting techniques from an Agile perspective. In the time we've got here, there are two key ones I want to focus on. So those are the ones that probably have the biggest influence in terms of the direct software changes and from a way we develop software, or can potentially develop software from a better perspective. And this is the test-driven development, the continuous integration aspects associated with that. So within those practices, we've now got a new set of processes and tools that have come along. And these have come out of the growth of Agile very much in the sort of server IT world. And many of those tools are now quite mature in their environment. If we look in the context of the traditional V model, and the V model is still very, very important to any sort of system design associated with this. We have obviously requirements, design, construction, how we have the unit integration and system test applied to these particular ideas. Now, if we look at the ideas of these Agile techniques and where they fit, we can see that TDD very much is focused around unit tests, traditionally been unit tests. There are variants of this, and people you may hear talk about sort of things like behavioral driven development, BDD, which is more about system tests, but really TDD is our main driver to look at the way we don't do direct code construction, and this looking at the unit test idea, which I imagine most people are familiar with. And that's a well-proven area, certainly in the safety world and the security world. There are many tools that exist that have done good test development. So test is one of the stronger areas. Continuous integration, the CI area, is more focused on looking at the integration aspects of bringing software components together and ultimately into the system components. And what I'll do is I'll spend a little bit of time looking at these two areas and seeing that where some of the changes to philosophies and the tools have come about that allow us really to start addressing these ideas. The first one is TDD. The basic principle behind it is to aim to move away from our traditional model. And the aim of traditional model is that we develop our code, we develop our units of work, we build and compile those, we then write the tests and exercise those, and then based on the outcomes of those tests, we say, do we believe it's functioning as expected? And if not, then we go through a debug cycle. And that's very much been led by using traditional IDEs coming from the traditional Visual Studios, and obviously there are tools like the Kyle tools that have been around for many, many years to allow us to do this sort of development. So we have interactive debugging sessions, standard breakpoint tape models where we'll break and step and evaluate. TD tries to change this, saying, well, there's a very simple premise here that if we write tests after we've written the code, then one of the downsides of that is that the tests are naturally influenced by the code we've written. So if we try and swap this around, so it takes a slightly different idea in that the first principle of a TDD model is that we start with the tests. And this, if you think about from a system design perspective, has a feedback that if you cannot define the test, then you probably don't know what you're trying to do. Now this of course a lot depends on the type of product you're building and whether it's exploratory or execution based models in terms of how much do we know about the system and how many unknowns there are. But driving in line with this is a way of working. Now traditionally version control systems, some of them can be quite onerous and quite bulky. I come from an SCCS background and went through the subversion models. But as part of this drive towards this concept of agility is a much lighter model in terms of version control, and probably the biggest influence there has been Git. There are other ones out there, Mercurial will probably be the second one, but certainly Git is the dominant version control system out there. And Git it's a very, very powerful tool, has many facets to it, one of them being distributed working as well. But one thing that changes is a very lightweight branching model. And for many people who've worked in a more traditional, say, subversion model, this is quite a cultural change in trying to change your emphasis in terms of branching regularly and branching always. And this is quite counter to work. So Git has evolved and has become a very standard tool in terms of doing versioning management within this, because we need this to build we'll see later how this influences our agile continuous integration model. So our first principle is we're going to write enough test code to do a build. So we start off, and like I say, the principle is we write the tests first, so we have to think about the tests. Now this is potentially one of the Achilles heels of TDD, and there are tools out there to help you look at and coming up with tests, and there's various tests, and things like Tessie is a very good example of a tool that actually helps you think about what tests you should be running and designing the tests. On the back of that, there are test frameworks that make testing. And one thing about TDD that has changed again is that you write your tests in the language you're testing. So for example, if I'm writing in C and I'm doing embedded C, there's a very nice framework called Unity supported that allows you to write your C tests in C, and it builds and links in with your application program associated with that. And another bizarre thing about TDD is the first thing you do is you write the tests to fail. So you want to prove the test can fail initially. Now, again, that sounds quite strange, but this is again proving the test time is correct. Once we've gone through that process, then the idea is we write only enough code to pass the test. And this is where the branching model comes in, the Git lightweight commit model comes in. It makes it very easy to manage these stages we go through and have this very simple capability of rollback. So it's not onerous. So we need this lightweight support from things like Git and Unity to support us. So the idea is we write only enough code. And again, this is another difficult thing to try and adapt to, and certainly for somebody who's done many, many years of software development as I have, is to change this mindset where you don't over-engineer too early. You just write enough to pass that particular test. Part of the TDD cycle is this concept called refactoring. So refactoring is before we go further, is saying, can we clean up the code base? Can we improve coupling and cohesion? Can we improve the intrinsic quality of the code? And again, tools have developed around to do code inspection aspects. So we can look at this code. The principle here is that when we make any refactoring changes, is we can reapply all of our tests to check that any changes we've made to improve the code base. Now, the thing about refactoring, you don't add any new code or remove any behavior. You're just improving the quality of the existing code base as possible. And you need this lightweight test model. It's a very, very fast cycle of test models using things like Unity, so that any changes we make, we can retest very quickly that we haven't broken what we've done before that associated with that. Once we've done that, the other side around Agile is this clarification of concept of what we call definition of done. And this again links into things like Scrum. So the definition is being, and this goes back to being able to write tests, is are we absolutely clear before we start developing this unit of work is what has it got to do? What is its basic requirement? And can we articulate that requirement? And we have this cycle we go through, and the idea of this cycle is very, very fast. We're talking minutes to do each test cycle, the idea. Now, sometimes the refactoring may be quite a lot of work, sometimes implementing just enough code may be quite a lot of work, but the idea is we have the term we use is cadence here, that we're going through this fail, pass model as we develop the tests. And then we get to the point where we're saying, yeah, we believe that we've got all the appropriate tests required for this particular unit of work. And this is then committed, and I think from a Git term, and merged back into typically what's called a working branch. And that at that point then can have a further set of tests applied to it. We'll see an example of this. So we can see this very, very clear model we're running through of this, and sometimes called the red green model, the traffic light system associated with that. As I said, so the tools that have come out, Git is probably the most influential in that area from a versioning control perspective. If we then move on and look at the idea of continuous integration, and this is probably the biggest area from an embedded perspective, where we get a huge variation from the potential we can do in a desktop system or even say a cloud-based system, is how far can we actually take continuous integration. So the principle of continuous integration is that users are working locally. We're working on this TDD cycle, we have our local tests, and we have ways of isolating our code from its environment. And the main phrase we use there is something called test doubles, or more traditionally something called mocks. And this is very important from an architectural design perspective, is that if we don't have a good architecture, we can't do this. But assuming we can do some sort of isolation of the code, so this assumes we're not necessarily writing drivers, because obviously there we're very, very close to the hardware, but assuming we're sitting above a driver level, the idea if we have an isolation layer and our code, we can mock or simulate the environment we're working to, and that allows us to work on this particular unit of work very easily. Once we've done this commit and we feel it's happy, then we have a stage build service. And again, a tool that has come out, there's a number of different vendors who support them, but probably again, the leading tool in this area is a tool called Jenkins, and again, I'm sure many people are familiar with, which is a build server. So a build server has the ability to sense a change in a repository. So when you commit, you commit to the local team branch, for example, the Jenkins build server will automatically detect there's been a change on the repository and do a clean build. So it'll pull down the new code with all the existing code and have a definition to actually go through and rebuild this. So we're ensuring that when I've committed anything, that what I believe is correct is actually still going to integrate with my team, what my team is working on. Assuming it passes that set of tests, it can then get forwarded to a further build server. So we have this idea where we might have, for example, something called a feature branch. So again, this depends on how we've partitioned the architecture in terms of vertical and horizontal architecture aspects. So this gets pushed out, and this is where there'll be generally further integration. So we might be integration with code outside of the team and wider library code example. And this may not be done purely on a sensing perspective, but on a periodic perspective. And a good example, many larger teams will work on something like a 2-hour cycle here. So every 2 hours, the feature branch will go through, look for any new committed changes come from the team branch, so they've gone through their particular path, and then pull those in and do a broader search and rerun a whole set of tests at this particular point. So automation of tests is absolutely central, the ability to automation of tests. Now, at this moment, we're still isolating ourselves from the hardware. Assuming we go through that phase, then we get a green light through that, then we may set up, for example, on a 4-hour cycle, another build server, build session, where we're doing broader sense. And in this environment, the very powerful model is if we can be running on something like an architectural simulator. So a tool that's again has grown in its use and becoming more and more popular is QEMU or Quick Emulator. And this allows us, for example, to simulate things like the Cortex-M family. So we can run a Cortex-M3 or a Cortex-M4, even down to a particular architecture. So we could be running an STM32F4, for example, and use certain GPIO aspects and doing a degree of simulation. And obviously it's limited here in terms of the accuracy of the memory system and the accuracy of the IO system. But the benefit now is that we're moving into a model where we're doing cross-compilation. So we're using the ARM cross-compilers at this point, where previously we probably would have been using host-based compilers like standard GCCs or standard standard Intel type compilers within this. So this gives us a good example to test, and we may be able to do a degree of runtime execution tests at this particular point. And certainly companies have this built up. Our final test is, do we have this then potential, which we may then run every day, is a full system test. Now this is probably the biggest challenge from an embedded perspective. There are companies that do this, but this takes planning from the outset in terms of understanding the test harness and test capabilities, where we ultimately have the capability to run the full tests on the real hardware, or obviously maybe prototype hardware at this point. So we can see we build this model where we're going through, where ultimately we want to have this repetitive, and the tests that get applied at each stage change as we go through. They move from being very unit-based tests on the left through to broader system-based tests on the right. And this then lends itself to a broader team working, where we have different teams working on different areas, that the automation of this goes through this particular process, where we have the very left-hand side is where we're focusing on integration, and we're assuring that as we build, the dependencies across teams are very quickly caught if they don't align. The middle section are very much about aiming of ensuring stability of the product. So at any point in time, every day, we have a clean build, a testable clean build at the end of that. Finally, through obviously the final aim is this idea of doing regression testing and ensuring that any changes are made, because obviously this is designed to deal with bug fixing as well, is they're also checked through the complete system build associated with it. So Jenkins again and tools like build servers again have matured. They're to degrees now. These can be done necessarily in the cloud. So smaller companies have the capability to be able to use things like Amazon Web Servers to do quite large builds, but still be able to bring the code back locally to run as a local test. The challenge of build servers, and probably anybody who's been involved in it knows this concept of breaking the build, is as we go through, is suddenly somebody says, well, it's working for me, but when we do some sort of stage test, then that test fails. And this has always been a challenge, is how do we ensure that the build servers and the environment that the programmer is using match in terms of even simple things like compiler configuration parameters, the preprocessor directives, but even the compiler version. In terms of, are they using the correct version of the libraries, etc. And this has always been a challenge associated with anybody doing build server, and this is certainly not unique to embedded. And probably the biggest step forward here has been the growth of this tool called Docker. So Docker, again, is based on something called Linux containers. And the nice thing of Docker is, because it's grown so rapidly in the last, it's really only been around about 4 years, it is now available for both Windows platforms and OSS platforms, Mac platforms, as well as traditional Unix-based environment. So it's gone from more of a very Unix-based environment to a broader environment now. For example, I run Docker quite happily on my Mac. And the idea of Docker is that you have this concept called a Docker file, where within the Docker file we can clearly specify the build requirements. So we can set up the base image. So for example, I can say, okay, I want to build against Ubuntu 16, which is the latest long-term strategy, or there are abilities to do builds against Windows platforms as well. So that's establishing the baseline for the tool set. So I might be pulling in a tool set like Clang, or I might be pulling in the ARM GCC tool set or a Kyle tool set at that point, What build tools am I using? So am I using CMake? I may be using something like Stones to help me do the make rather than having to simplify the traditional make files. What libraries do I require? So am I using the Embed SDK, for example, if I'm looking at an IoT-based system, am I pulling in the latest version of the Embed environment? And if I'm using a debug-based technology, for example, I might be using SimSysDAP to be able to push the code down to my particular target. Now, the purpose of using a Docker file and the benefit of a Docker file is it's a very simple file that can be distributed and used locally. So I can ensure, for example, if I'm running on Windows, I can do a build against a Linux build. So I'll actually build in what's called a container. You can think of it as a very lightweight virtual machine, but it will install all of the tools locally to that particular Docker image, that container, and do the complete build of that process. So it means I can work locally, whether I'm working in Windows or OS X, and do my builds then. But when I feel I want to commit it, then I can commit it through Docker first. I can do a local Docker build to check that everything I've thought of is correct. And then that Docker file becomes part of the build. So my Jenkins build servers can recreate that exact same build environment. So as we go through the series, we're ensuring that my cross build is exactly the same from my local environment through to the actual system-based environment. And I said around that, there are a huge number of tools that have grown up. So Jenkins, Bamboo, for example, are build servers. Git is, and let's say Mercurial. People are arguing Mercurial is slightly easy to learn, but Git is more prevalent. Docker, you might have heard of Vagrant. Vagrant is sort of a heavyweight virtual machine used by things like VirtualBox to do the same purpose, but Docker is much lightweight. And then setting up the tools, we've got a whole load of tools such as GitHub and Bitbucket to allow you to manage Git repositories remotely. This is very good for team working, distributed working, and as I mentioned, tools like Jira. And sitting alongside that is not only Scrum and XP, but other techniques around the Agile. So Agile is far more than just these tools. It ultimately is a set of values and a mindset. And things like Lean sit in there, Kanban sit in there as techniques. Now, obviously, this sounds too perfect to be true, and there's sort of the holy grail or nirvana of software development. And the answer is yes, at the moment it is. There are certain, so what we can do at the moment from an embedded perspective is cherry pick a number of these facilities associated with it. So there are certain key aspects we can see, but there are still certain challenges, and one of the main challenges we see in the embedded environment that a lot of tools out there don't work particularly well with things like the Jenkins tool. So they're not designed to be used in a more of an automation fashion. So key to automation is having command line interfaces, CLIs. And this is the ability to invoke from a command line. And many traditional tools that have been around for the last decade or so are very much based around user interfaces and GUID. So you desperately need both support for that. You need to be able to do exactly the same at the command line you can do through a tool user interface as well. The other thing people get caught out with is if they try and apply these techniques like TDD and CI is if you haven't really got good architectural design and good partitioning between architectural layers, it is near on impossible to get this to work. You'll fall down very, very quickly when trying to do the integration. It becomes very, very onerous. So there is a need for upfront architectural planning associated with this. Another challenge we see is that Agile does take a mindset. And the dangers is that people try and force fit Agile into companies without broadening that. And if you Google the search Dark Scrum, there's a very good article called Dark Scrum, which explains where companies had these problematic changes of trying to apply Agile. So like I say, it's been around for many, many years, probably a decade or more in the sort of server-based world, in the IT world. It's still relatively new in the embedded world. A number of companies have been trying it, but they've gone through various problem areas. So like I say, I'd recommend Googling Dark Scrum and seeing that it's more than just let's drop Scrum in here and think it's going to work for us. It's like most things, it's a cultural change. I would say the biggest overall problem that I see at the moment is almost all the mainstream Agile work and many of the Agile tools assume it is only a software-only problem. So everything about continuous integration, all this drive for continuous integration and TDD and BDD and all these great phrases pay very little attention where I've got custom hardware. So again, there are missing bits in the jigsaw puzzle at the moment in terms of how far we can take continuous integration. It doesn't mean we shouldn't strive for it, but it's again being realistic at the moment of what can we get from Agile today, and where as a business would you need to look quite early in terms of planning. I said, so planning about architecture, but planning about build, planning about saying what practically can we do from a continuous integration perspective. Because this has become such a major topic, we've actually also putting together a Agile conference where it's all announced there at the moment to try and broach many of these issues. So again, it's not got all the answers. Hitex are one of the main sponsors for this, and we're very privileged that we've got some guest speakers from Dyson Ericsson Television who have applied Agile techniques to real-time embedded systems and will be speaking about their experiences.